strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous.
Hello friends, good evening. Welcome back to YES online platform and preparation league. And this is a day 1 continuation part for SSC JE and RRB JE syllabus analysis and the preparation strategy. Today I will complete the yesterday's part, that is a syllabus analysis, and after that I would like to teach you a small topic of digital electronics. That is very simple and very small part, and from that part the questions are found in SSC JE. Of course, 1 mark is given in 2019 paper and that too, they can't make the complicated questions from that area as it is not officially given in the syllabus, right? As I told you earlier, we need to focus on the fundamentals, and today's lecture can give you most of the 50% of the information about the digital fundamentals, and the remaining things even you can study from the textbooks also. I am talking about digital electronics, and the basic electronics is little bit lengthy topic, right? It is around 60 to 70 hours of topic, right? And see, my dear friends, the first and foremost thing for the preparation, not only for public sectors, even in GATE and ESC or any competitive exams, you need to develop your own short notes. But how can you frame the short notes? We need some direction. So that direction we can get it from the classroom notebook, right? So the classroom notes is very, very important, right? See, and for each and every subject, the separate classroom notes, and then you need to develop your short notes from the classroom notes. And with this classroom notes only you can understand the important areas, what should be considered and what are the topics has to be ignored as per our syllabus, and based on the importance we can move on. And previous year questions, even you might be preparing like from last 1 to 2 years, but if you couldn't touch even single PYQ, you trust me, my dear friends, 100% we can't have the minimum confidence levels to touch the problem in exam hall, right? If you could able to solve all the previous year questions very easily, your preparation level should be 100%, but the previous year questions can give you 100% confidence. If you could able to see the questions are just 10 to 15% of the preparation level. We are giving that much of priority for the preparation, not only for the basic level, we need to go for some high standard level. And you can understand that as I am able to answer any type of question only when you finish the PYQ solutions in your own. You should not copy the solutions and you should not copy the formulas from the classroom notes or any objective books. And this will play vital role in the preparation. You can download the SSC JE, RRB JE last few years question papers, and then you can you have a look at the paper from the first question to the last question. Then you can understand the level of the question. After completion of the preparation, you just try to solve them, right? And not only the SSC JE and RRB JE, for example, Maha Transco papers are available. AP and TS, Genco, Transco, Discom papers are available. Like that, you can solve your state level public sector unit like previous year questions and ESC question papers. If possible, as I said earlier, in the first part, you better to collect the question papers of engineering entrance test. It is an exam conducting for the students who are coming from diploma to the engineering second year as lateral entries. So that is the best level for us to prepare more number of, and that is the best exam for us to collect more number of questions. And this is the second priority, engineering services exam. You can take the objective paper. If you find any contradictory question, please you do not change your notes or main content based on the one or two wrong questions. If you find any contradictory question, you just leave it. You just be strong with your fundamentals and the subject, right? By look at one or two questions, you should not change your opinion about that particular topic or that particular numerical standard value of anything in your subject, right? And so be careful while preparing these objective bits from different objective books. There are here and there, maybe you can like find one or two mistakes, maybe printing mistakes or even sometimes maybe the conceptual mistakes. You just ignore them. You just go through the concept. You should be very good in the concept. You read the question. You understand how the examiner framing the questions in this particular topic. Sir, if I find two correct answers for the same question, yes, you can find priority in your notes. There are some questions like that, but according to the priority, we need to select the appropriate option, right? And this is just one of the source, and the practice and expected questions. Material is available, just I'm talking behalf of ACE Academy, right? This is a SSC JE and the same syllabus, as you know, valid for RRB JE also, right? So you can get some content, and not only the previous year questions and not only the SSC JE and RRB JE questions. You can find some of the ISRO questions, DRDO, BARC, and some state level exams, and some of the best what we call standard ESE objective bits also. There are some standard points, standard objective bits for every topic. You can find them in ESE exam, and those questions also copied. Of course, not exact questions sometimes. Sometimes some small modification might be done. Just the values might be changed under the category of expected questions. So you can build your own subject. At the same time, you will get some confidence also, and we can predict how the examiner will going to frame the questions in our exam, right? Definitely, this type of objective books can help you. There are so many objective books available. You can choose any book, no problem, but better you choose one book and you follow it. Textbooks. In our basic electronics, as I told you, there are two parts, digital electronics and electronics. Electronics is a big one, of course, very big one. Around it is 60 to 70 hours of a topic. Digital electronics, we need only 5 to 6 hours, even in offline or online, even live or recorded classes also. 5 to 10 hours is maximum for digital, as it is not officially included in the syllabus. Okay? So, for digital electronics, I don't suggest any textbooks. Just normal, your engineering or maybe from the diploma notebook is sufficient. Or you can take any basic level textbooks if you have. You just refer it, because questions are from very basic level, right? Only two topics you need to focus more and more: logic gates, Boolean algebra, and then you just have a look on logic families, their categories, applications. Mostly it takes 1 to 1.5 hours only. Okay, right? And see, reference textbooks for electronics part. There are so many textbooks, Neiman, Whitepad, Boyle's Thread, almost both are same, but as content wise, right? And see, this is a Ramakant only for operational amplifier, especially for op-amp. But I don't suggest, if you are interested, it's okay. Otherwise, I don't suggest different textbooks for different topics. In basic electronics, operational amplifier is one semester subject. And the remaining parts are belongs to like ECA, electronic circuit analysis, and what we call PDC, pulse and digital circuits. Diploma level, electronics 1, electronics 2. There are two different subjects. So for subject wise, instead of purchasing the textbooks, you better to choose one book in which you need to find everything. So in that way, I can look at the Sanjeev Gupta. This is one of the best book for SSC JE and RRB JE, basic level, just to build the fundamentals. Everything is available. All topics you can find in one book, right? But this is a little bit high standard book. Remaining all are, means they can definitely help you for the GATE and ESC exams. For SSC JE, basic level to moderate level, and we need to get huge content. So that I don't say everything is available in the book, but you will get some confidence. If you have any doubt in that particular point, you can find it in the textbook. And not only this, you can find any textbook, but you try to purchase one standard book, right? And for digital electronics, as I told you, no need of any textbook, but if you are interested, then you can go for either R.P. Jain or A. Anand Kumar. If you want more number of numericals for each and every topic and subtopic, you can select this. But both are good, standard books, right? So for us, definitely we can find sufficient information from these two books, right? And the topic is, as I told you, Boolean algebra. See, my dear friends, if you find one Boolean expression, this is not the time to discuss the construction of a Boolean expression and all. You can find the Boolean expression in two different forms, SOP form and POS form. SOP form and POS form. Sum of products, and POS stands for product of sums. SOP stands for sum of products, POS stands for product of sums. In the universal design, you can understand actually why we should go for the Boolean expression in two different ways, like SOP form and POS form. Each form is having its own importance based on the design. And whatever may be the Boolean expression, let us say a Boolean expression f is equals to, just as it is an example, f is equals to AB plus A. This is a Boolean expression. The use of this particular Boolean expression and construction is having its own. Of course, it's decided by the designer. And my requirement, if two variables A and B are two sensors, A and B are set to 1, means if they sense something, I need to turn on the motor so that I can write an instruction like what we call Boolean expression A dot B, f is equals to A dot B. If both are 1, 1 and 1, 1, that 1 is nothing but 5 volts output. The 5 volts can turn on the relay, relay can turn on the motor. It can control the power supply to the motor. Just a simple example, I hope you can understand with this example exactly why and how we need to construct a Boolean expression. And throughout the subject, we can find only two logics, my dear friends, logic 1 and logic 0. Logic 1 represents some high voltage. We can also write it as H. But keep it in mind, high voltage, undoubtedly you no need to worry about what type of logic family it is. By default you can memorize it. Logic 1 or high, logic high can be represented with 5 volts. Logic 0, we can represent it with an alphabet L. It can be minus 5 volts, negative voltage, or it may be 0 volts, even it may be the 0 volts, right? So as I wrote one expression here, F is equals to AB plus A. This is a Boolean expression. If I want to realize it, I need to go for the circuit design. And see guys, to implement the circuit, F is equals to A plus AB. See this, I am talking about this circuit here. F is equals to A plus AB or AB plus A, no problem. A plus AB. We need one AND gate and one OR gate. This is A and this is AB. AND operation between A and B. And then these two terminals I am connecting to an OR gate. Right? And now the cost of the circuit. Please remember, cost of the circuit means, it doesn't mean that price. It means the number of components or units. Here we need two logic gates, one OR gate and one AND gate. But it is not necessary to construct with two different logic gates by using two units. If you could able to minimize it, you can minimize the number of components automatically. As the number of logic gates are getting minimized, the internal circuit complexity decreasing, power dissipation decreases, and indeed cost of the circuit is also can be decreases. So in that way, if I go for the minimization task, you can find A as common. If you take A out, 1 plus B, 1 plus anything is 1 into A, F is equals to A. It means, please try to understand, no need of any circuit to implement this. In this box we have two variables A and B, only two variables A and B. Output is A, you can directly take a wire like this is nothing but A. If A is 0, output is 0, A is 1, output is 1, that's all. No need of any logic gates. This is called the minimization process. So there are different ways to minimize the given Boolean expression. There are different ways to minimize a given Boolean expression. In that, the first method is Boolean algebraic method. In Boolean algebra, we have some postulates, theorems and laws. If you go through all of them, we will have some smart mind, like by look at the expression we can immediately get a logic how to minimize that Boolean expression to get the minimum number of literals. Don't confuse, literals means just the number of variables, maybe in complement form or uncomplemented form. Simply number of alphabet, simply A, AB, B, all are the literals, right? But there are some drawbacks for the Boolean algebra. If the Boolean expression is lengthy, like if it is having more number of variables and more number of literals, then minimization leads to make complications. And we cannot say the minimized expression is completely or final minimized expression or not, because there is no standard protocol, standard rule in the Boolean algebra, like a step-by-step procedure. So to overcome this problem, there is some second method of minimization, that is Karnaugh map method. We can say it as K-map. And after K-map also we have some other method for the functions which are having more than 6 variables, that is a tabulation method. But you no need to worry about it. You don't have K-map and tabulation method in your syllabus. You need to focus on only the Boolean algebra, right? Okay, so that is the reason today I'd like to give you some basic idea about all the rules and regulations, theorems and laws of the Boolean algebra. And with the help of them, I'm going to solve your previous SSC JE and one RRB JE question, and then some of the 2 questions I have selected from ESE papers, 1 question I have selected from the Engineering Common Entrance Test paper. For the practice and to understand how the questions will be from the basic level. This is from very, very basic level, right? Okay. Coming to the idempotence law, there are some rules as just logic gate wise and logical operation wise. Let us assume A is a variable. A dot A, it is an AND operation, is equals to A. It is also called as AND law. You can easily identify as it is AND operation is being processed by this particular part, we can say it is AND law, but you just remember the basic overall operators at the output. After minimization or after substituting the values of ones and zeros, whatever the output you are going to get, that can be called as an operator. Whatever the output we are going to get, that can be called as what? Operator. That's it. A dot A is equals to A. If you could not able to memorize the things, you can substitute ones and zeros just for what we call, just for simplicity and for your confidence only, right? See, A dot 0, 0 AND operation with anything will give 0 only. A dot 1, A, B, whatever you want, you consider no problem, is equals to A. If A value 1, final output 1. A value 0, final output is 0. A plus R operations, A is equals to A only. 1 plus 1, 1, logical operation. We must call it as a logical operation. 1 plus 1, 1, and 0 plus 0 is also 0. That's it. But we can't say A plus 1 is equals to A, because A can be anything. A can be either 1 or 0. If A is 0, 0 plus 1 is 1. If A is 1, 1 plus 1 is 1. That means what? Finally output is 1. So A plus 1 is 1. A plus A bar. You just substitute the value of A, 1 plus anything. Sir, if A is 0, 0 bar value 1, 1 plus anything is equals to 1. So that A plus A bar is equals to 1. Sir, why don't you write A into A bar, sir? Yes, you can write A dot A bar also here. A dot A bar AND operation will always gives 0. A dot A bar will always gives 0, right? So these are the some of the idempotence rules, and even you can write A into A into A, or AB plus AB is equals to AB, and A into A into A is equals to A only. Not only the 2 times, you can write them multiple times, and multiple variables also. ABC plus ABC. I think you can guess. As A plus A is equals to A, ABC plus ABC is equals to ABC. That's it. Before entering into the commutative law, associative law, distributive law, De Morgan's theorem, and etc., we need to know something about the dual and complement of a function. And it is very easy. If time supports, we'll talk about the complement and duality and its application. It is little bit a lengthy topic. But now I am going to give you just the basic idea about how to write the duality and complement. Just a basic idea how to write the duality and complement. Let me take one Boolean expression, f is equals to AB plus C bar D bar, right? This is a given Boolean expression. You just remember while writing the duality, you just interchange and or operations. By default, for both dual and complement, ones zeros should interchange. Most of the times we cannot find it, but if you find them, interchange. Ones and zeros interchange. I am talking about the main operators and or operator. In duality, and or operator has to be interchanged. See, this is AND operator. You write it as OR, A plus B. Dot. Sir, how can you say dot? This is an AND operation because OR operation should change into AND operation. Dot C bar plus D bar. But if you observe, I think you may notice this point. C bar is written as C bar, A is written as A, B and D bar, like that, as it is. But if you see the complement of the same function, for the same function, I am writing the complement. A bar plus B bar. I think you can guess what I am going to write. Dot C plus dot C plus D. Instead of writing C double bar, directly I am writing C. So you should understand one point here. Here also you can find some similarities. AND operator changing into OR operator changing into AND. But A is written as A bar, C bar is written as C double bar. C double bar means bar get cancelled, so no need to write it. So each and every literal, A is a literal, B is a literal, C bar is a literal, like that. Each and every literal should be complemented while writing the complement. Just you remember complement, we are doing complement also. Each literal should be complemented. Okay? And apart from that, AND and OR operators by default should be interchanged as it is, as in duality. So this is a common point between duality and a complement. In both duality and complement, AND and OR operators should be changed. But in duality, we are not changing the complements. We are not making any complement to the literal. But here literal has to be complemented in the complement part. This is only the important point and conversion. You please try to remember, there is a chance to ask this type of questions directly. They will give you one Boolean expression and they will ask you, write the duality or which of the following is a duality and complement of the given function. So duality and a complement. But just I wrote the question and answers here, but I have explained the step by step. But you need to write. If you do the paperwork, it can go to your brain, right? Otherwise it will stop with your ear only, right? So that is the reason you try to write something. While writing this, you write the rules also. Then only you can memorize it. And you can create your own questions and also, right? Questions and answers. Yeah, coming to the part of Boolean algebraic rules, commutative law. As per the commutative law, you can write AB is equals to BA. And you can write duality for them. A plus B is also is equals to B plus A. This is a commutative law. It cannot help us most of the times in the minimization, but you remember, I can't give you the proof now because if I start giving the proof, we need more time for each and every law and theorem. Commutative law is applicable for all logic gates. Except NOT gate. Commutative law is applicable for all logic gates except NOT gate. Associative law. A plus B plus C is same as OR operation between AB and then resultant OR operation with the C, A plus B plus C. And second line is just duality of that. A dot BC is equals to AB dot C. And you just remember only the commutative law and associative law for the logic gates point of view. Safe side only, questions are not found, just for safe side. Associative law applicable or otherwise, the following logic gates follows the associative law. Those gates are AND gate, OR gate, exclusive OR gate and exclusive NOR gate. These logic gates can follow the associative law. Follow the associative law. The remaining gates will not follow the associative. The remaining gates will not follow the associative. Sir, what are the remaining gates, sir? NAND gate and NOR gate. Of course, NOT gate also, but these two are important. Not follow the associative law. NAND and NOR does not follow the associative property. And the distributive law, not only in the simplifications and direct questions are found from the distributive law, and the distributive law can help you in the universal logic gates such as NAND gate and NOR gate and their conversions. Right? This is not the time, but while studying the NAND and NOR gates, designing any other gates and functions using NAND NOR, the distributive law will definitely help us. It is a straightforward relation A of B plus C can be written as just like a mathematical expression AB plus AC. But students will take it as very serious the second part, but no need. If you know the first part, and everyone knows, of course, you can write the duality of the first part to get the second part. A plus BC. A plus BC is equals to A plus B dot A plus C. A plus B dot A plus C. And this is very important theorem, and you can find the direct questions from this. In some of the competitive exams, the questions are found direct relation, not like link up with some minimization and Boolean expressions. Consensus theorem. According to this, AB plus A bar C plus BC can be written as AB plus A bar C. Actually, we have some proof for this. We need to take the redundant term here, but I don't want to make it complicated. BC, A is missing here, you need to choose this term logically. You should write here A plus A bar, and if you multiply it, in the second line, you will get some common terms between first minterm and third minterm and second minterm and fourth minterm. After writing A plus A bar, BC into A, BC into A bar, total those two and these two, total you will get 4 minterms. And in every 2 minterms, you can find some common terms, and then it is going to resolve as AB plus A bar C. Right? So, you just remember only the point AB plus A bar C plus BC, this will be the result. AB plus A bar C. And its dual form is very easy, you know that. Similarly, you can write A plus B dot A bar plus C dot B plus C is equals to A plus B dot A bar plus C. And this is very important. And my dear friends, please you take this result. AB plus A bar C. You just take that result and see what I am going to write here. From that result, AB plus A bar C, you can easily memorize it, can be written as, see this, A and C, and then B A bar. We can write it as A plus C dot, we can write it as A plus C dot B plus A bar. This is a transposition theorem. If you want, you can prove it, but after literal redundant rule, it is maybe simple, but no problem. Let me try this. You take the RHS. This is a LHS, this is a RHS. Let me take the RHS part. A plus C dot B plus A bar. A into B, AB, plus A into A bar 0, plus B into C, BC, plus C into A bar, this is A bar C. And see, my dear friends, this is nothing but AB plus, okay, this is A bar C, plus what is this? BC. What do you know about this? AB plus A bar C plus BC. AB plus A bar C plus BC is nothing but AB plus A bar C. So this is nothing but AB plus A bar C LHS. If you start the simplification from RHS, we obtain the LHS. But you try to understand the procedure and how to adjust the variables here in the law and theorems. Please, every time you don't go for the proof unnecessarily, right? Just once, if you know that, yes, there is a proof, but you need to remember it confidently, that's all. But every time you cannot do this in exam hall, it takes more time. And in SSC JE, especially in our SSC JE and RRB JE, we need to select the option in just 10 to 15 seconds. We should not use more than 10 to 15 seconds time. Of course, no need. And De Morgan's theorem, majority of the times in the minimizations, it will help us. A dot B dot C whole bar, it's like a NAND operation. We can reconstruct the same function like this with OR operators, but you need to take the individual complements. A bar plus B bar plus C bar, and still it can hold the same logical value. It means you can substitute ones and zeros at the left side in place of variables, and if you substitute the same values of binary in the variables of RHS part, left side and right side, the logical value either 1 or 0 will be same. Of course, this method is nothing but the method of perfect induction. No need to know the method name and all. You just, if you want, you can test with ones and zeros. Right. Similarly, the reverse is also possible. A plus B plus C whole bar. You can write it as A bar dot B bar dot C bar. In every minimization technique, and most of the times you can see these things in universal gates again, NAND and NOR gates design, the De Morgan's theorem will definitely help us, right? And replace with OR, and right in terms of OR operators written in terms of AND. But be careful how to adjust the complements. And this is also one of the important rule. You may not get the direct question, but every time it can help you while solving the problems. It will help you in the minimization. This is one and only the relation majority of the times can help us in the problems, right? What exactly the redundant literal rule? For this also we have proof, but you try to memorize it logically. There are different ways, but I am going to give you two forms. You need only two forms, only two forms. A plus A bar B can be resolved into A plus B. We have proof for this by using the duality technique, right? But I am not going to give you the proof, you need to memorize it. This is one form. And my dear friends, see this, A plus A bar B equal to A plus B. And now what I am writing, please observe it carefully. And you can guess the answer actually. A bar plus A B bar. In place of B bar, it can be anything, no problem. The students who are watching this video, I think they can guess. You just compare with the first one, you will get the answer for the second one. I can write it as A bar plus B bar. Without any proof and simplifications, if you want to prove that, you can substitute ones and zeros left side and right side, LHS and RHS logical values will be same. And already I told you, my dear friends, these two rules are very, very important. You just focus on this portion. A plus A bar. See, after A bar something is here. You should write that something. You are neglecting this A bar, that's all. A plus B will come as operator. A bar plus A dot B bar, you are neglecting this A, you are writing A bar plus B bar. So A plus A bar B equal to A plus B, A bar plus A B bar is equals to A bar plus B bar. You should remember this, please. Let us solve this question, and statement is actually, there should be one statement here, no problem, you can write the statement. Minimize the given Boolean expressions. For all the upcoming questions, statement is same. Minimize the given Boolean expressions. And my dear friends, redundant literal rule and idempotence rules and sometimes De Morgan's rule will help us a majority of the times while solving the problems. And you need to observe the common term, you need to find the common term from the given Boolean expression. But you might have done lots of practice in your diploma and BTech also. in this way. But sometimes not only by identifying the common terms, we need to apply some extra logics that I am going to discuss with simple example questions. As they are 1 mark questions, I can't select the questions from GATE or some high complicated levels. I have selected only the questions from very basic level, and within the basic question itself, I would like to show you the logic. And in each and every question, you can find something different, model or let us say logic. Okay, this is a straightforward question, of course. I think someone can find some common terms here. F is equals to, I think you can find AB common. AB, what is this? C bar plus C plus, you write this min term as it is, A bar BC. You know well C plus C bar is equals to 1, so that I can write it as AB plus A bar BC. And this is important observation, so please observe it carefully. I can take B as common here. If I take B as common, see what I am writing, my dear friends. If I take B as common, what can I write? A. Okay, A plus, I am changing the color also so that I can make you people to sense some logic here. This is A plus A bar C, because B is out, B is a common, right? So what I am writing here, A bar C. Did you get it? A plus A bar C. I think you can see the answer directly with white color from redundant literal rule. We can write it as B of A plus A bar C is simply A plus C. So that answer is, you can find this as an answer. Sometimes they may multiply them. You can find anything in the options. AB plus BC. I am going for the next question. Minimize a given Boolean expression. B C bar plus B bar plus C. You better try this question first, and then you can compare the solution. See, my dear friends, if you observe carefully from here, I am rearranging them. Of course, same thing I am writing here. B bar plus B C bar plus, you write this C as it is. What did you get from here? B bar plus C bar from the literal redundant rule. I am not changing the color, directly I am writing this. And now this is the time to observe the function carefully. What did you know about it? C plus C bar, A plus A bar is how much? 1. So that output F is equals to anything plus 1, you know already, 1. So 1 plus anything is 1 is the answer. I am changing the slide. This is little bit complicated as per our exam concern, but it can help you as practice question. . Please observe the entire Boolean expression carefully. You write V as it is, and if you observe carefully, you can find V bar as common. W plus W bar, this is X, okay? W bar X plus W bar X bar Y. I think you may get the point. A plus A bar, this entire expression must be assumed as B. A plus A bar B is equals to what? A plus B. In place of A, I am assuming V. In place of B, I am assuming this entire Boolean expression. So, this will becomes like A plus B. I am writing V plus this entire function. In this entire function, again you can take, see what I am writing here. W, I am writing this function only. Plus, in next line you can go for common, but here only I can do it. V bar common. Then what will be the result? X plus W bar out, because it is common. X plus X bar Y. And then you cannot minimize it at any cost. This is V. Observe it carefully again. A plus A bar B. A plus B. So, V plus W plus A bar B. A plus B. I am writing this portion only. W plus X bar Y. And again you need to observe it carefully, this portion, X plus X bar Y, X plus Y. So what is the final answer? V plus W plus X bar Y is X plus Y, so that X plus Y. And we can't minimize it more than this. The final answer is V plus W plus X plus Y. I am going for the next question. This is the direct question from consensus theorem. AB plus A bar C plus BC, you know, you try to recall. I am writing it directly. AB plus A bar C. To answer this, please you just observe it carefully, different examples. In this example, I am assuming F is equals to 0. Then any intelligent guess, what is a F complement? F complement means F bar. You can write it as 0 bar. F complement means F bar, 0 bar. You can also write it as FC complement, means 0 bar. What is the value? 0 bar value is 1. And from here, I am writing 0 into 1, 0. What it means? One function dot its complement. The product is always 0. This is case 1 example. In terms of variables, how it looks like? F is equals to A. F is equals to A. What is a F complement? We can write FC. FC means F complement. A bar, sir. That's all. F complement is A bar. That's fine. That means F dot F complement is nothing but what? A dot A bar is how much? 0. Next example, multiple variables. F is equals to AB. Let us say AB bar. Okay, AB bar. Then what is a FC? What is a FC? You need to be more attentive here, please. What is a FC? Sir, whole bar, sir. Yes, correct. A, B bar, whole bar. What is a A, B bar, whole bar? That implies F complement is equals to, apply De Morgan's here, A bar plus B double bar, bar get cancelled. So, A bar plus B. What is this? F complement. But no need to take whole bar and apply De Morgan's. We can save that time by writing the complement directly. Because we know how to write the complement directly, you go back and please watch the video. We have discussed duality and complement. What is the rule for complement? And or operators should be interchanged. Value, I mean alphabet, for simple understanding I am talking like this. Alphabet means literal. Okay, technically we should call it as literal, has to be complemented. It means what? A should be complemented, B also should be, I mean B bar also should be complemented. Okay, A bar and replace with R, B bar whole bar, bar get cancelled. And now you see both are same. A bar plus B, A bar plus B. Even you can take whole bar and apply De Morgan's, you can directly write the complement. Complement. But what we have done here, we took the complement and this is after De Morgan's. This is after De Morgan's, right? So, from here also you can write. You don't need to multiply them. You can directly answer it. A B bar dot A bar plus B, F and F complement. A bar into A, B into B bar. What it means? One function F and its complement Fc are always equals to 0, right? So, with these three cases, I have given 3 examples here. I hope you people got the clarity. A function and its complement product is always 0 is the bottom line of the story. A function and its complement is always 0, right? Now I am going for, just observe the screen carefully for 5 seconds and then I will go for the next screen. This is a question. So why I have spent this much of time for this? My dear friends, blindly don't jump into the Boolean expression minimization and don't try to do something. Spend some time to understand the question and analyze it carefully. And then you can proceed for the valid step. The question is given like this. This is one term multiplied with some other term. Some students may directly start multiplication, 100% correct. But it takes more time. Think smart. This is a function. Let us assume it as x. Okay? Assume it as x. Or otherwise, let us assume it as f. Assume it as f. Just observe carefully. AB plus C bar D, AB, A bar, dot, plus B, B bar. R operator, change it into AND. C bar D, C plus D bar. Did you get the point or not? What is this? What is this? F complement. What do you know? F dot F complement is always what? 0. So, the direct answer is 0. Okay friends, in the next class 3.0 Day 3, we'll continue the session. I will solve some more questions, some logical questions and very important models from the Boolean algebra, from simple topic, okay? And then I will go for some questions and if possible, some of the information like small topic I will select from electronics part. Any topic if I select, I need minimum 1.5 hours, and it will be like too lengthy in live session. So that is the reason I will try to select one simple and interesting and important topic from the electronics part, or otherwise I will directly go through the simple questions and I will explain the surroundings. I will explain the basic background of that question and I will solve it. Like that I will do something, but don't miss the day 3 class, right? Right, my dear friends? Goodbye.
in ESC 2020 and ESC 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online